So if we instead have a system of inequalities, the way we handle this is to look in terms of the values that satisfy all of the things in the system. And thinking back to terms we defined when we were talking about compound inequalities and absolute value inequalities way back when in the first chapter, we can think of this in terms of that idea of the intersection. Again, we're trying to find the overlap shared between all of the things that we have. So, best way to understand this, as usual, is to look at an example. For this example, we want to graph the solution set of the system x minus 3y is less than 6, and 2x plus 3y is at least negative 6. Where, again, it's not super obvious what happens when you have something in terms of that general form equation of a line. We can rearrange it to maybe get a better sense of each of those things in terms of slope-intercept and then get the locations a bit quicker. Or we could also just graph these pretty easily in terms of intercepts, where we have the one line, the second one is solid because we have that non-strict inequality, whereas the first would be dashed for the fact that it is strict. So from there, we need to make some determinations about what's going on, which half planes go where. And we can do that again in terms of the origin both times, because the origin isn't included in either line. So for our first part of that system, we have 0 minus 3 times 0, is equal to 0, which is definitely less than 6. Meanwhile, for our second, we would have 2 times 0 plus 3 times 0 is equal to 0, which is definitely at least negative 6. So we would have the point 0, 0, the origin, included in both. So what we want for our total region is the intersection of both parts containing the origin there, the one above the solid line and above the dashed line, like so. We're including both of those at the same time because the things to the left of that solid line wouldn't be included and the things to the right of the dashed line wouldn't be included because they are in one but not the other. We only take the things that we have in both parts. And to finish us off for the semester actually, our very last thing here is going to be looking at how we can take these ideas and apply them to some real world models. Well, one in particular.